I'm Anna from BOC. We are a spin-off of the University of Vienna. By now we have over 250 employees, and we focus on software in the area of IT-supported management approaches and especially about business process management. And today I will present you our approach on designing digitization solutions, and I will present an example of a paint production process. So we support the design of digitization solutions, focusing on the identification, the creation, and the evaluation of solutions for the digitization of production processes. And especially, we want to make digital twins more transparent, better understandable, and more concrete. We would like to equip them with open interfaces to facilitate fast integration of diverse technology providers, or to integrate and test several potential solutions. Digital models are used, for instance, to interpret data, to reduce the complexity with a graphical representation of relationships and dependencies, or also to foster acceptance among diverse stakeholders, or to integrate different modeling approaches and also different description formats. We use physical experiments that are created to integrate experts that might not be familiar with conceptual modeling, to consider physical artifacts accelerating the creation of digital twins of production processes, and to test effects that might arise solely in the physical world. For instance, the behavior of digital devices may change depending on its battery status, and so on. An open source demonstrator is used for the exemplary integration of external services, third-party providers on top of business processes, and for the step-by-step transfer towards real data and also real systems. And the demonstrator is also used for integration and testing purposes. To design a targeted digitization solution for an industrial use case, the OMILAB innovation environment is used. BSc has 1 out of 15 academic and industrial nodes within the OMILAB nonprofit community. And the innovation and experimentation environment provides a variety of methods and tools, for instance, modeling software, physical infrastructure, and those tools and methods facilitate the creation, the transfer of conceptual innovation ideas towards industrial use cases. 3 major abstraction layers are considered here, starting with the business-oriented view. So, for instance, production scenes can be designed using design thinking approaches that may foster a better understanding and also a common communication of the business idea. Physical aspects and technologies are tested via so-called proof of concepts using sensors, robotic devices, IoT infrastructure to evaluate their appropriateness for specific industrial use cases. And conceptual models bridge the business and the physical considerations via digital models, for instance, with business processes. In the following, chemical process production process, specifically for a paint production, is shown, and this is used as a sample to depict how the digitization design can be supported using such an innovation environment. And all layers of the OMILAB will be considered, starting with the production processes on the business layer, over the creation of digital models and simulating those on the conceptual layer, to finally testing and integrating targeted technologies and also physical equipment, for instance, RFID tags on the proof of concept layer. And applying the innovation environment, we can support the identification of digitization potentials, also tackling digitization requirements of SMEs. And for instance, the paint production companies, which is also one of the Change2Twin pilots, wanted to digitize the production process to facilitate traceability and also to ease the so far manual documentation. And furthermore, they aimed at digitizing the raw material warehouse for a real-time inventory, and also provide additional customer services by digitizing their product information. And starting and staying with this paint production sample, on the left-hand side, you can see a picture of the real-world production, and this is mapped to the laboratory setup via simplification and abstraction in order to reduce the complexity and also, for instance, the physical space. And we use an association in form of a tea production sample, as it can be provided as a common understanding, as producing tea nearly everybody is familiar with. And this results in the OMILAB lab setup you can see on the right. And this has quite similar characteristics to the real-world production. The overall production process was abstracted to focus on the digitization relevant aspects and also on these production process stages. And to map the real world, respectively the laboratory setup, to the digital world and establish a kind of digital perspective of the production process, the concept of event-based logs was introduced via using timestamps. And those timestamps can be collected in different ways. And one option to collect event logs is in form of a virtual interface. And in a real-world production company, for instance, handheld devices such as tablets or smartphones may be introduced for digitizing the documentation and facilitate also the traceability. Another option to capture such events is the introduction of digital technologies and also related physical equipment. And in this sample, we equip the order with an RFID tag and the relevant production stages with RFID readers to collect the information while simulating the production process in a physical environment. The digitization of the raw material warehouse, for instance, was conducted by introducing slots for targeted materials towards a real-time inventory monitoring, and providing such a modular system for the creation of digital twins in this innovation environment. A discussion platform and also first solution ideas can be designed and experimented very quickly. The identification, creation, evaluation of digital solutions can be facilitated by using patterns. For instance, in this sample, we count the production process events via RFID technology. Another pattern would be approximation. For instance, the raw material can be approximated by using cameras and also image recognition in the warehouse. And due to the experimentation environment, several patterns, technologies, and also physical solutions can be tested and integrated. For instance, instead of RFID technology to document the production stages, also e-beacons or QR codes may be an option. And finally, also third-party services such as time series databases can be incorporated by following a microservice approach. The captured data can then be presented in form of a dashboard combining capabilities for monitoring, simulating, and querying the production processes related to manufacturing. And based on the production process models and also related log data, we facilitate dealing with questions such as, is the production process currently in line with the production plan? Can the next 3 orders be produced? Is there enough raw material for doing this? And when will the current production be finished? Dealing with these questions, the production process can not only be monitored in the real world, but also forward-looking perspective can be provided, for instance, via simulation and digital models. For instance, as you can see here, PetriNets can be used to create event information, and this event information may be related to production processes and allow for further data analysis. Also, advanced knowledge-based simulations, building upon discrete event simulation, for instance, can use several input factors ranging from production line performances to seasonal information, for instance, brighter paint colors may be favored in summer. And further on, also execution times, costs, expert ratings, and so on can be considered, following an approach that uses a weighted sum of all the inputs. And the digitization design of industrial use cases can be further leveraged by introducing smarter, intelligent services. And so far, several AI-based and related services ranging from, for instance, semantic to simulation approaches were tested on top of the physical experiment and integrated into this process environment. And to name only a few, image recognition can, for instance, be introduced to approximate the material status. Chatbots can apply it to communicate with the digital twin, or also the production process can be simulated using various simulation approaches, for instance, fuzzy logic.
Anna, can you conclude?
Yes, thank you for the reminder. Please feel free to contact me in case you have any further questions about BOC or about the presentation right now, and we would be happy to support you in establishing your physical experiment. Thank you very much for your attention.
Thank you very much.